We see robots everywhere, and we want to know how to control them with AI. Well, next up on the Cozy AI Kitchen, you'll find out how. I am delighted to be able to bring a special guest to the kitchen, an expert in robotics from General Robotics, Griffin Norris. Chef Norris, welcome to the Cozy AI Kitchen. All right.
Hey John, nice to be here.
So robots, what's that about?
I mean, they're such a great tool where, for all the kind of things that we humans, maybe don't want to do, maybe it's something boring or, dull, you might want to just have a robot go out and do that for you, bake you some cookies in a kitchen like this. But just using them is really hard. It's kind of, we almost underestimate how much our brain is doing in terms of perceiving the world around us, acting, and, kind of just interacting with the world. And then getting a robot to do that is not a straightforward task. You have to kind of blend all of these different disciplines between, good computer programming discipline, being able to leverage AI models, and then all of that just places a huge burden on the programmer working on that. And so we at General Robotics are trying to make that easier, trying to let you do useful things with your robot fast. And so that's what I'm delighted to show you guys today in this demo.
A General Robotics solution, the AI era.
That's what we're going for.
Well, Copilot, turn off the kitchen.
So what I want to show first is kind of, showing kind of some code generation. So typically you'd have to, go and figure out how does my specific robot work and
go to the docs,
read that, fail a lot. And then if you want to start doing something with an AI model, you have to repeat that whole process over again.
Fail more, be confused.
Exactly.
Yeah.
Spend a lot of time reading things, scratching your head.
Small model. Where do I get that?
Yeah, exactly.
Which one?
And now what we've done at General Robotics is kind of take our API, where it's the same API for an entire class of robots. All quadrupeds have the exact same controls.
Wow.
And we've taken our AI inferencing service and we've written up our docs, we've put them on an MCP server, and we've made them available for robots to call.
You made it easy for AI. Made it easy for agents.
Not for
makes it
users,
easier
for us.
There we go.
So what I'm going to do now is I've connected my Copilot with that MCP server.
Yep.
And now I'm just going to talk to it in natural language, and I'm going to say, how could I make my go-to stand up and let's do something really simple, move forward a little. Okay, and let's try that.
So it's hitting your MCP server right now.
Exactly. So we'll actually be able to see that here as it goes through, kind of giving us visibility.
Right.
And here we can see how it's going to do that. So it's going to explore the docs tree first. Mm-hmm. So it will literally call tree on it. Right. And I'll click allow on these. And in fact, just to speed things up for this, I'll just say to always allow tools in this session.
Just like we'd look for the nav and the hierarchy.
Exactly.
Right.
And so now it'll read through that. It'll find, we can see here it's saying, I found the go-to. I'm going to read that file. And now it's going to immediately start writing something for us. Great. And now, just to be sure, I'm going to ask it, are you sure all of the types are correct? Just to make sure.
Double check.
Exactly. And I have a little experience with this agent. Sometimes it gets those velocity types a little wrong.
Upgrade your model, everyone. Keep going. Yep.
But now we can see again, it'll just, in fact, this case, it just searches, it greps for the types, reads that resource, figures out whether it made any mistakes. So kind of keeping it quick and snappy here. That's now it'll think about it for a second. And of course, we can go and read everything that it's doing if we want to use this as an opportunity to learn for us.
Right. And this is a general quadrupedal robot API, basically.
Exactly. So if I wanted to take this from a go-to and swap to another quadruped that we support, it would just be that one line of code, just saying, hey, instead of go-to, maybe this is a ghost robot.
Got it.
So now I'm going to say, great, now can you execute the script for me?
It's cool because you could also control dog robot APIs in a virtual world.
We do, in fact, do that. We, at General Robotics, we have both our own in-house sim. So that's called AirGen, built off of AirSim, which came out here at Microsoft. And then we also support Isaac. So if we're doing kind of more locomotion training for robots.
Oh, nice.
Great. So now it's suggesting to run that script, and I'll allow that.
And we'll see it starts up here.
It went to your docs. It 3D printed the program to map to our desired goal.
You can see now stood up. Oh, and it actually made a little mistake.
Oh yeah, passed it.
And now it'll fix it on its own.
Autopilot.
And now I can try and run it again. And it'll again start up the connection to the robot. And now it should step forward. And so we saw it took a little baby step forward there.
I saw it move forward.
And so now let's maybe add in something a little bit more interesting.
Yeah.
And let's call one of those vision models. So there's a little camera built in the nose of the Go-To.
It's eyes.
Its eyes. And now we'll sprinkle in some reasoning on top of that. So I'll ask it, could you also get an image and then use a model to get a scene description for me?
You're doing model provision of a VLM, et cetera, in the cloud.
Exactly. And then we're providing all those docs so that it makes it very easy. You're not having to worry about distilling some giant VLM to run on a Go-To or something. Instead, it's just 1 or 2 lines of code to call a model.
And how's the edge involved?
So the edge can kind of be as involved as you want it to be. So if you're maybe worried about really safety critical applications, you could run something on the edge. That could be on the robot itself. That could be on kind of a edge server where in the same room you're running the AI model, passing it over. But in many cases, especially for kind of development, it's much easier to just take kind of this pre-made, pre-baked, store-bought list of models and kind of iterate quickly and figure out which one works the best for my use case.
Got it.
Okay, so it's still working here, just making sure it's getting all the API keys right. It's researching. And this is another great thing about using an LLM is that while it's cooking, so to speak, I can go off and I can chat with a colleague or get a cup of coffee and come back and hopefully the work is done. So I should try to install that. That's already installed. And now it'll hopefully run that script for us. And of course, what we're seeing here is that when you are doing code gen and you're having to start up the server, turn it off, it's having to read all these docs, that can take quite a bit of time. Very powerful, but the LLM has to spend a lot of time thinking about what it's doing. So in a second step, we'll actually examine how we could speed that up a little bit, but I won't spoil anything yet.
Well, I also imagine with multi-agent systems to write code simultaneously, that must be changing your way of doing all this work.
Exactly. It actually, I very infrequently have to write code myself. I'm using, models from Claude, models from OpenAI through Copilot to kind of help me write all this code. Great, it's now updated the script, and now we can run this again.
It's going to stand up, sleeping, move forward.
Exactly. Great, and now we should see it in the terminal.
Oh,
Great, we can see, so the image shows a room with a black and pink wall featuring a large window. On the left side, a man in a black shirt.
From General Robotics.
And pants, that's always good. Stands near the window, while another man in a white shirt and khaki shorts stand near a tripod and lighting equipment.
Saying Packers.
Exactly.
All right.
Gotta represent. And then there's also a green ladder in the scene. So I'd say that did a pretty good job. And that only took us a couple of minutes. I haven't written a single line of code so far. And I have kind of scripts that I can start iterating on myself.
And it can do a feedback loop once it has a scene description.
Exactly. So now I could start saying, I want you to do X until you see description Y.
Wow.
Great. So now let's step over and look at kind of that second scenario that I was talking about where we're saying, okay, I've already written kind of a set of tools or a set of skills. And now I want to provide those to an LLM and not have it worry about all the nitty-gritty details of, how do I access the API, having to read the docs, and instead say, these already work. Use this tool to do this thing, and do whatever you need to do to achieve what the user wants to.
Right, so step one is make the library of skills you might want to use, and then step two is apply the libraries at a higher level with planning.
Exactly. So let's step over to that. So let me open that. And now let me say Python start server. This is actually starting up another MCP server. So we've built up our tools. We're going to host those as an MCP server, and then we can connect an LLM. It could be, anywhere on your network. So you could be 2 buildings over, and you could send commands to your robot to say, hopefully one day, go get me a coffee, or I forgot something at home, go get that for me. Okay, so that's up and running. Now let me.
Your robot as the MCP server. Not bad.
So we've now connected to that MCP server through Copilot, and now we can start to just kind of ask it to do things in natural language. So let's start and figure out what kind of tools our robot has. So I'll just ask, can you please tell me what tools you have from the robot dog go-to? And again, the LLM will kind of reason on this. It'll figure out what tools it has. And we can see we have kind of a nice little list here of, it can describe the scene. It can count objects, so doing some of those kind of vision tasks. And then we can also have some basic, move forward, move backwards, rotate.
And these are pre-built tools. Yeah.
Exactly. And so I already know that these should work. So I can now ask it, great, can you now rotate to the left a little? So now it's, again, very important. It's asking us, for kind of our approval to do this.
Human in the loop.
Exactly, helping us keep safety. The LM doesn't know if the robot is about to, step on a fragile plate or something.
I'm far away.
Exactly.
I'm far away.
That being said, while it is very important for safety, in this demo, I know what the tools are. They're all very benign. And so just to keep things speedy, I'm just going to click to always allow the tools in this session.
Chef Norris has guardrailed the robot so it won't hurt us. Nice job.
And so we can see it took a step to the left, and now let's start doing something a little more interesting. Let's say, can you now keep turning to the left until you see at least one toaster?
We place the original semantic kernel toaster in the back of the go-to. Let's see what happens.
Yeah, so it'll plan. It's going to start rotating. Let me actually pull up the view here so we can see what it sees.
Whoa. This is the go-to's eyes. Oh, look at that.
So it's updating each time.
Right.
We can go and we can watch what the model is doing. We can see it's, as we would expect, it's calling rotate. It's then calling count objects to see how many toasters it sees.
Right. It's a while loop for the robot.
Exactly. You see some objects are starting to come into view. None of them are toasters, so it should keep rotating. And we can see now, we see a nice little bounding box.
Wow.
We can see it detects the toaster. Okay.
I see. And then you could make a skill like navigate to, which doesn't exist right now.
Exactly. So I've kept it kind of simple here as an introduction.
Right.
I don't want to bring in something too complicated.
Right.
But you can, because the skills are written in Python, you can make them as complicated as you want.
Cool.
You can have a obstacle avoidance skill. You can have
Interesting.
navigation skills, et cetera.
So the world hasn't seen these kind of skills on GitHub or big repo that doesn't exist yet.
No. At least not outside of General Robotics, but we're definitely cooking up some interesting stuff.
Neat.
So now let me, just to kind of finish this example, let's say, perfect, good job, always good to be supportive of our LLMs when they do well.
Good dog.
Now can you take a step forward and get a description of the, let's say of the toaster. Takes a step forward, and now it's calling a describe scene tool. And now we see the robot sees a white toaster and 6 colorful peppers are arranged on a black table with a white wall and blue-green wall in the background. And if we look at the image, we can see that roughly corresponds. We can maybe forgive the model for thinking it's on a black table.
It's a VLM.
Exactly. You could always swap that out. That's another advantage here, is that we're not tied to some 20 billion parameter model doing everything. We can just swap out these individual pieces if we need something different.
Totally. Thanks for the cool demo. Copilot, turn the kitchen back on. Thank you, go-to. Okay, wow. This is amazing. This is so many parts of the AI revolution, and robotics originally was the home of AI in the 1970s and 80s. So as someone who was from that era, I appreciate you. There are people out there who are discovering that robots can connect to the cloud with coding environments, et cetera. Do you have any words for them because they'd like to get involved but may not have the time to get involved?
I think now is actually a great time to do that because, before you'd have to go and spend, hundreds of hours reading, documentation, getting a lot of firsthand experience with, how do I control all of these individual robots? You'd have to stay up to date with all the latest AI models. And now with, LLMs, you can use them not only to help explain new concepts to you, but also to help you implement them and to be kind of a little bit faster in that loop. And we try and make that a little easier at General Robotics. I have to kind of represent my company here, but it's just a great time to be in robotics because you can just move so quickly with LLMs.
Okay, so all you out there who don't have one of these yet, this is coming. It's already here. Thank you, Chef Norris. All right, keep on building, everyone.